Hey guys, alright, we're going to be looking at ionic bonds inside ionic compounds. Okay, now, what an ionic compound is, it's very simple. Is a compound composed of cations, the positive charged elements, and anions, the negative charged elements. They come together in a specific ratio to make a neutral compound. Okay, like you can hold salt in your hand, it doesn't react with you. Sodium chloride is salt. Sodium metal is explosive if you throw it in water. Chlorine gas is poisonous. It can actually harm you. Together, they become neutral, and you can sprinkle it on your food. The two elements themselves are dangerous, but then they neutralize each other. So, if you look here, we have a little ionic compound, and you see that sodium is right next to chlorine. They bond, okay? And this whole setup here has chlorine, sodium, chlorine, and they alternate, okay? There's an attraction force holding these guys together. So an ionic compound is a metal plus a nonmetal. Okay, as you just saw, it's arranged in a 3D pattern. And it is electrically neutral. Okay, ionic bonding is the electrostatic forces that hold ions together in ionic compounds. So, you have your bond between Na and Cl. Why does the nonmetal always take on a negative charge? Well, that's the one that's always going to be taking the electrons from the metal. So the cation loses its electron to the nonmetal. And that's where the electrostatic force comes in, form an ionic bond. I thought this was cute. It's a little image of the little girl anions outside. And they are attracting all the boy ions on the inside. Notice all the boys are positive, all the girls are negative, and they're pulling all the cations to the window because the nonmetals are pulling the metals' electrons. Okay, so ionic bonding. Metals give their valence electrons to nonmetals to complete the nonmetals octet. Now, metals have a lot of electrons, but only the ones in the highest occupied energy level are the ones that are going to be available for bonding. Okay? Not the inside ones. The outer shell, or the outer energy levels. Now, in an ionic bond, we talked about electronegativity, but with an ionic bond, there's a special number, and it's 1.7. If you look at any ionic compound, find their electronegativities, subtract them, larger minus the smaller, you're going to get a 1.7 or greater. So let's take a look. So we have a couple here I chose. We have potassium chloride, sodium nitride, cesium sulfide. So in this case, we found their electronegativities from the table in your textbook. Okay, we're going to do larger minus smaller. So Cl minus K. So it's 3 minus 8 is 2.2. N minus Na, 3 minus 0.9. S minus Cs is 2.5 minus 0.7. And this is right from the periodic trends chapter, which we already discussed and we already talked about the electronegativities. Okay? On the left side of the periodic table, the electronegativities are low. So the metals have a lower electronegativity. On the right side of the periodic table, they are higher. They have a more higher ability to attract electrons. Okay? So because they're greater than 1.7, they're going to be ionic. And we're going to look at the numbers lower than 1.7 in the next chapter. Okay? That's a different kind of bond. It's a covalent bond. Now, what is a chemical formula? Very simple. It shows the kinds and numbers of atoms in the smallest unit of a substance. For example, NaCl and MgCl2. Okay. Now, what is a formula unit? This is an interesting definition. Well, a formula unit is the lowest whole number ratio of ions in an ionic compound. I throw this term around there a lot. Formula unit is basically the ratio at which an ionic compound is written. How many of the metals to how many of the nonmetals. Okay? So the ratio depends on the charges of the ions combined. So some have +1, +2, +3. Okay, and some nonmetals have -1, -2, -3. Depending upon their charges determines how many of the other species of ion you need to make it neutral. So we're balancing the charges here to make a neutral compound. Okay, so here we have Na and Cl. Sodium has a +1, chlorine has a -1. So you need one of each. Very simple. Mg plus 2Cl minus 1. So you have 2 pluses and 1 Cl minus. So you're going to need 2 Cls, okay, to balance the Mg2 plus. Okay, so you'll have 2 Cls to make the 2 minus to equal the 1, 2 plus. All right. Now, Al plus 3, Cl minus 1. Cl has a -1, so plus 3 plus. So you need 3 1 minuses to make it neutral. So these are the ratios here. 1 to 1, 1 to 2, 1 to 3 to make a neutral compound. Okay, now 3 properties of ionic compounds. Very important. All crystalline solids, are crystalline solids at room temperature. So ionic compounds are all solids. There's no liquid ionic compounds. They have very high melting points. And if you take a hot pan, throw salt on there, it's not going to melt. It will not melt. They also conduct electricity when dissolved in water or in a molten state. So if you take a crucible, put your salt or your ionic compound in it, heat it up really, really hot, it'll become molten, and you can put 2 wires in there and it'll conduct electricity. The same as if you were to take the salt, dissolve it in water, make salt water, homogeneous mixture. You have your positive and negative ions floating around. Therefore, you put your 2 wires in there from a battery, it'll conduct electricity. Okay? Now, the last term is something called coordination number. This is interesting. Okay, coordination number of an ion is the number of ions of opposite charge that surround the ion in a crystal. Okay. So let's take a look at salt, NaCl. I don't want to get too deep into this, but let's just look at one. You'll understand them all. Okay, here we have the crystal of salt. Na is your red dot, Cl is your blue dot. So you have, we'll get this one in the middle, this red dot here. And the atoms adjacent to it, you have a blue, a blue, a blue, a blue. So you have 4 on the horizontal plane here. Then on the vertical, you have 1 above and 1 below. So you have your 4 vertical here, 4 horizontal, and your 2 vertical. 4 plus 2 is 6. So sodium chloride has a coordination number of 6. So there's 6 chlorine atoms surrounding the 1 sodium atom. Okay, so NaCl equals 6. 6 Cl atoms surrounding the 1 Na. Or vice versa. If we go over to, if we had a larger picture of this and we took the blue, we can see that there'd be 6 reds or 6 Nas surrounding it. Okay, but that's that. That's coordination number. And we are going to look at another portion of this section, and we are going to write out the formation of ionic compound notes. And it's a little more elaborate. And we're going to continue on that on the next PowerPoint. All right?